All right, welcome to part 2 of section 10.3. I know you couldn't wait to get to this part because you were full of suspense from part 1. Some more exciting terms. First of all, a reference triangle is a triangle that's formed by drawing a perpendicular from the terminal side of the angle to the x-axis. We'll look at a picture of this in just a moment. We're going to be labeling the sides of our triangle using r. R is the distance from the origin out to the terminal side, or really is the terminal side, and xy is a location on the graph. Now, since the r is a distance, it will never be negative. The r is always positive. However, the xy is a location on the graph, so just as usual, they could be positive or negative depending on what quadrant you're in. Going back to the same pictures that we used when we were learning about reference angles, I'm going to draw in the reference triangle. So here, just dropping the perpendicular from the terminal side down to the x-axis, forming this triangle, and then labeling the sides. So this, to get to this point right here, we would be going over x and up y. They're both positive in the first quadrant, and the radius of this is r. The distance, the measurement from 0, 0 to here is r. Coming over to the 120 reference triangle, again, you can draw on these perpendiculars anywhere because the ratios will be the same. No matter where you draw it on this 60-degree angle, remember, the triangle can be very small or as big as our parking lot or bouncing off a satellite, the ratios are the same. So here, this bottom part, in the second quadrant, the x is negative. Coming up here, the y is positive. And of course, the r is always positive. Looking at a reference angle here for the 225, drawing in the perpendicular from the x-axis. In the third quadrant here, the x is negative and the y is negative, and again r is just positive. The reference triangle for the 330 would be anywhere right about here. X is positive, y is negative, and r is just r. All right, this next part I don't think you need to write down, but you need to understand that when we're finding the trig ratios of the reference angle, those trig ratios are the same as the original angle we started with. So sometimes it confuses students. If we're doing the sine, cosine, and tangent for 120, we found the reference angle to be 60, we drew in the reference triangle, and then we're finding the sine, cosine, and tangent of the 60. And then students will say, well, we're not finding the 120. And that's why I wanted you to make sure you understand they're the same. The ratios are the same. The only thing that's going to be different is the sign could be positive or negative because of what quadrant we're in. So just, if you need to convince yourself, do these two on your calculator for any of these, sine, cosine, tangent of the 120 and the 60. The ratios will be the same, but like I said, the positive and negatives will be different. So please don't let that confuse you. Yes, we're going to be working with the 60, but we're finding the trig ratios for the 120. All right, this is a diagram you will most definitely want in your notes. It may not be so useful to you for regular angles, but it will be extremely useful to you when you hit a quadrant angle. Now, when we have a regular angle like this angle theta, put it in standard position. Your book calls the reference angle of theta, calls it theta prime, so I labeled this reference angle theta prime. XY is any point on this terminal side, so I just put it right there. And then let's just draw in our perpendicular so we have our reference triangle. So in this triangle, this is meant to be generic notes for any quadrant, so I'm not going to be real concerned about the signs of positive or negative right now. We will do that in each problem. So let's label this side x, this side y, and this side r. So let's just have this in our notes, that the sine of theta, which we know is the same as the sine of theta prime, is opposite over hypotenuse. So let's just fill in sine, cosine, and tangent. Now r is always going to have a value, and it'll be a positive number. So these first two denominators are no problem, but we just need to clarify that here x cannot equal 0. And it will on two of the quadrant angles. All right, cosecant, secant, and cotangent are inverses. So let's write in these three trig functions. And obviously, when y is in the denominator, y cannot equal 0, and likewise with x. So just to please note, r is always positive, so the signs of x and y will determine the signs of these trig functions, whether they're positive or negative. All right, these 4 steps are very useful for those of you who like to have things in the list format. So please pause the video, write these down if this is helpful to you. First, you find the reference angle, draw in the reference triangle, label the sides of the triangle, and use those sides to find the trig ratios. All right, let's look at an example. State the exact values for all 6 trig ratios for 210. So following our steps, first drawing the angle, finding the reference angle, comes around 180 and 30 more degrees would be about like this. The reference angle is 30. Draw in the reference triangle. Let me try that again. That was pretty crooked. All right, maybe I'll get a perpendicular. There we go. Now when it comes to labeling the sides of the triangle, we don't have any information to go on. So you could really label these many different ways because the ratios will always be the same no matter what the size of the triangle. So in the unit circle, we will always put a 1 here for the radius, but when we're not in the unit circle, we can choose some numbers that could be just a little easier. For instance, we know the relationship between the short leg and the hypotenuse in a 30, 60, 90. The short leg is half. So if you would like to choose this to be 1, you could double it to get the hypotenuse is 2, and then that would mean that the long leg is the short leg times the square root of 3. So after I have labeled the sides, like you could have called the hypotenuse 10, the short leg 5, and this 5 square root 3. The trig ratios are going to turn out the same. You always need to pause here a moment after you label the sides and check your signs for positive and negative. We're down here in the 3rd quadrant. Therefore, our x would have to be negative and our y is negative. And now we're ready to proceed. So the sine is opposite over hypotenuse, gives me a negative 1/2. Cosine is adjacent over hypotenuse, negative square root 3 over 2. And tangent is opposite over adjacent, which would be negative 1 over the square root of negative 3. So the double negative takes care of itself. We need to rationalize the denominator. So we'd end up with square root 3 over 3. And now for the inverse trig functions, we would get for the cosecant a negative 2. For the secant, it would be negative 2 over square root 3, and then rationalizing that, negative 2 square root 3 over 3, and the cotangent, 3 over square root 3, and then rationalizing that, we would get 3 square root 3 over 3, which simplifies to just the square root of 3. In this next example, all we are given is a point, 5, negative 12. So I drew an xy axis and plotted this point. And that's it. Now they want 6 trig ratios. So once again, find the reference angle. Draw in the point, from the origin down to, so draw a line from the origin down to the point 512 and make your reference triangle. Sure wish I could draw with this thing. And label your sides. Here the x is a positive 5, the y, we're coming down negative 12, and we're going to have to find this hypotenuse by using the Pythagorean theorem. 5 squared, 144, and 25 is 169, so the hypotenuse here is 13. So now that we have all our sides, we can find the trig functions. So again, working off of the reference angle, the sine would be negative 12/13, and these are kind of nice because we don't have any square roots to worry about. The cosine would be 5/13, the tangent negative 12/5, and then the inverse functions would just be reciprocals. Alright, in this next example, which I think you'll find very helpful, I want to look at a quadrant angle. Now, you're going to need those notes we referred to earlier because they want us to do this without a calc. We want to use reference angles. But what's tough about a quadrant angle is there is no angle and there is no triangle. So let's attempt to draw a picture of this. Alright, not a real exciting angle to draw. But the 180 comes over and the terminal side is still here on the x-axis. So we need to get some values to work with. We need an x value, a y value, and an r. So this step is like the equivalent of labeling the sides of the triangle, except we don't have a triangle. Since the terminal side is here on the x-axis, you can pick a point to work with. Now let's not pick negative 432. Let's just, I don't know, we could just say we're going to go over 2. So we're picking this point of negative 2, 0. This point is on the terminal side. It will give us the trig ratios for the 180. So the x value is negative 2. The y value is 0. And recall that the r is always positive, and it is the distance from the origin, so we are 2 units away. So you need to find these. This is, like I said, the equivalent of labeling the triangle, and we use these then to find the trig ratios. So referring back to that part of your notes where we had the picture of the triangle with the x, y, and r labeled, and we had that the sine of the angle is y over r. That would be 0 over 2, which is just 0. The cosine was x over r, so that would be negative 2 over 2, which is negative 1. And the tangent was y over x, which would be 0 over negative 2, which again is 0. So now doing the inverse trig functions, cosecant would be 2 over 0, which we can't have, so we would call this undefined. The secant is negative 1, and the tangent would be negative 2 over 0, which doesn't exist, so the tangent is also undefined of 180. Alright, so this example should help you with your quadrant angle problems that you have in your assignment. Good luck. God bless.